Alright, so one thing that looks a little different getting into question number 7 is we don't see a dy dx, but we can change this y prime into dy dx so that it looks the same as the first couple that you should have done. And then let's go ahead and try to separate our variables here. So we don't want like a dx in the denominator. It really needs to be in the numerator. So I'm going to do this in more steps than it needs to be done, but I want you to kind of see where this is coming from. And since this dy is in the denominator here, I certainly wouldn't want to divide it over and put it in the denominator. So that tells me the y stuff's probably going to have to go to the left. I guess you don't have to move the 3, but you need to move the y over at least. And then here's our x stuff. So let me divide this by 2 plus x. So those cancel. So divide this side by 2 plus x. So it looks like in the left we've got this. We've got 1 over 3y dy. And over here we've got a 1 over 2 plus x dx. So even though it's okay I moved this 3 over here, my answer is going to look a little bit different in the back of the book, even though mine should be fine as well. But to be consistent with what they have here, I want to leave the 3 over there. So now, because we only have y stuff on the left and only x stuff on the right, now is a good time to integrate both sides. So this would be the natural log of the absolute value of y. This would be 3 times the natural log of the absolute value of 2 plus x, and we need a constant. Alright, so we have officially separated the variables and we have correctly integrated both sides. But most questions aren't going to finish like this. Even though you don't always have to get it down to a y equals, they're certainly not going to stop here. So this step, what they are doing to move forward is called exponentiating, which means we're going to take both sides of the equation and we're going to make it be the exponent on something. So I'm choosing it to be an exponent of e, because one of our logarithm properties says that if you have a number and its exponent is log of the same base, or the base is the same number of something, all of that just simplifies to be the something. So when I take this and apply it here, all of that becomes this. And this guy, we can go ahead and split it up, because when you multiply things with the same base, you add the exponents. Well, I'm going the opposite way. So I'm going to split these two up. Multiplying things with the same base could add the exponents. Alright, so this guy's going to end up being y. This is this same property again. This one up here. Apply it here. We'd have to move the 3 up as an exponent. That's another logarithm property. But now it's e to the log base of e of some stuff. So all of that stuff is going to go like that. And then technically over here, e is just a number. So e to the power of c is just a different unknown number. So we're going to just change this guy to just be, say, c. Okay. And the thing about this guy is he could be positive or negative. Like, we don't have enough information to determine if this unknown number is positive or negative. So technically, we can drop this absolute value sign, because our unknown constant could adjust and be positive to make it work with the information, or make it be negative to work with the information. So this would be the solution to number 7.